This is the Anycubic Kobra 3 V2 combo. Please excuse the mess in this video. I've been frantically trying to get my Creator Museum piece done in time for this year's open source, and I've been using the Kobra 3 V2 to get some of the prints done for it. You know, when I've seen people talk about the predecessor, the Kobra 3 online, it has always been hailed as the destroyer of premium printers. You know, why spend 800 or $1,000 on a machine when you can just buy the Kobra 3 and get this much printer for your money? And that is something that we'll have to keep in mind for this entire video. This printer is $250 and you can get it as a combo with the 4-spool multi-material upgrade, the Ace, I think it's actually called the Ace Pro, yeah, for $350. Plus minus a bit, sales and import fees always change the price, but that is the rough ballpark that we're looking at here. And honestly, for $350 for this printer with the MMU AMS Ace, I think is insanely good. But once you use it for a while, you start to realize why it is so cheap. You know, then you either start jailbreaking it or you end up somewhat limited in what you can do with it. But hey, that is exactly what made printers like the Ender 3 so popular and so powerful. They're cheap, they work well on a basic level, and then you can spend the time and effort to mod them and to improve them to make them the printer that you want them to be. And that can be quite an appealing way to use a 3D printer. So if you're interested in that, stay tuned and we'll check out what the Anycubic Kobra 3 V2 combo does and does not do. So philosophically and mechanically, this is and always will be an Ender 3. I mean, yeah. They say betslingers are dead, but this machine is living proof that they very much are not. There are a couple of upgrades from Anycubic that I do like seeing. For the X and Y axes, they're using metal roller wheels instead of the plastic ones, and on top of that, a wider track for the bed to make that platform more rigid. You get rigid belt tensioners on Y and X and a dual lead screw for the Z axis. Overall, mechanically, this is a very basic printer, but the mechanics are pretty well executed. Feature-wise, you get a load cell on the nozzle. This is a direct drive system, so none of the issues from a Bowden drive system. You get a magnetic PEI spring steel bed, a built-in webcam over here, you print that yourself, and a color touchscreen, which is off because the printer is quite noisy when it's running. And you know, that is where you can start seeing some of the cost savings that are being made. This screen is just straight up bad. Not only are they lying about this being a capacitive touchscreen, which it very clearly is not, but it also has some of the worst viewing angles I've ever seen on any screen. Even just the distance between your left and right eye has them seeing different brightnesses of gray on the screen, and it just makes it very uncomfortable to look at. Thankfully, the menus don't actually offer much functionality, so you won't be spending much time looking at it. Electronics-wise, from what I can tell, it runs the same platform as most of the other Anycubic printers, which is a Android-based OS on a Rockchip SoC, along with Clipper on a low-cost GD32 clone of an ST32 microcontroller. As you might expect, Anycubic isn't publishing any of the source code for their software or the software they're using and modifying. Thankfully, the actual electronics hardware looks quite decent. There are some instances where they didn't really know how to use a strain relief and some of the zip ties are quite loose, but it's not a big deal. And overall, I'm really happy to see that it looks like we've moved past the age of cheap printers automatically meaning a fire hazard from the electronics compartment. One pretty neat detail is that they have this printer set up with this little platform on the side here. So this is a prime platform on the far end of the X-axis. So it moves the nozzle all the way to the right, extrudes filament, and then as it moves back to the left, there's a magnet that catches a small ejector piston, pulls it out on a spring, and then it shoots the filament out once that magnet releases. I do like the simplicity of this, but the tolerances could be better. There is a pretty significant gap between the nozzle and the ejector wiper thing, so when the printer doesn't get enough filament purged onto the platform, too much of it stays on the nozzle, and that actually throws off the bed leveling quite a lot. That is my biggest issue with the printer, full stop. It has a lot of smart stuff built in to check all the boxes, but the way those features are being used ends up making the printer dumber than if they just weren't there. Now, I do want to talk about print quality too in a bit, but let's stick with the bed leveling for now. So, like I said, the nozzle has a load cell that it is mounted to, and that is the de facto standard way to level a bed these days. Totally fine. However, the way that the data from that load cell is being interpreted differs between printer brands. The best possible data that a printer will have to work with is always when the nozzle hits the bed with a sharp, clean impact. So usually there is quite an effort being spent on getting that nozzle as clean as possible before doing any sort of leveling or Z-probing on the bed. And then if the printer notices that that nozzle tap didn't quite feel right, it will go back to trying to get the nozzle cleaner or probe a different spot in a slightly different position. Not the Kobra 3V2. It has that purge ejector wiper and a little rubber brush on the back of the bed, but they don't work for getting the nozzle clean enough, and the printer just doesn't care. Between the purging and just gunk left over on the nozzle from the last print, I have always had to intercept it sometime between it heating up and purging its filament and it starting the bed probe, and somehow manually wipe the nozzle or take some tweezers and pull the plastic residue off. Otherwise, it would usually level way too low because that load cell didn't get that sharp force increase measured as the nozzle taps into the bed. This got so bad that sometimes it tried to print the first layer low enough that it stalled out its own extruder because it just could not get that filament out of the nozzle anymore. Now, I get that it's annoying when your printer regularly just refuses to start a print with a message like nozzle cleaning failed, but I think it's a much more annoying thing to find a printer ruined because it's peeling off or has the first layer smooshed into oblivion. I have seen this happen on the Kobra 3V2 in both directions actually. There was a streak where almost every print was coming out with the first layer way too low. But there was also a time, I think the first couple of prints, where the Kobra 3V2 was printing way too high, and prints ended up peeling and curling off of the bed. What makes this such a big deal to me is that you have no official way of fixing this behavior. It's just part of how the printer works, or doesn't. And you're dependent on Anycubic releasing a firmware update that completely rewrites the leveling process. When it works, the print quality you get is quite acceptable, though sometimes a little inconsistent. I've had some prints come out basically perfectly, and others a bit more borderline. Ringing is not much of an issue on this printer. It does have the optional resonance compensation dance it can do before a print, and while it also has the option to do a flow rate calibration before a print, I didn't actually see either of them changing anything about the print output. The printer doesn't tell you if it's storing the results from either of the test cycles for the next print, or if it reverts back to the hard-coded stock settings for input shaping and pressure advance. And do you need to rerun the pressure advance cycle after a filament swap if you've run it before on a different one? Nobody knows. The way that the flow calibration is implemented here is pretty different from the similarly named feature on Bambu Lab machines. What the Kobra 3V2 does is that it moves over to the purge platform and does a bunch of little test extrusions. Some short, some long, some fast, some slow. And it seems to use the load cell to characterize how the pressure inside the hot end behaves. And again, I don't know if this actually changes anything, but it does involuntarily show you another flaw in the printer's design. The hot end is mounted to a load cell that is simply way too soft, and you can see it visibly bouncing up and down as the extruder applies pressure. This is something that I think you can see in the print output. Whenever the flow rate changes, for example around corners or holes here, you get a bump in the extrusion. Not because the hot end is responding too slowly, but because it is being physically pushed down into the previous layer as the extruder pushes harder. If you want to physically fix this, you're going to have to mount in a different, more rigid load cell. Not exactly trivial, though someone might also find a smart way to compensate for this in software. So let's talk about the software. The slicer that Anycubic ships with the Kobra 3V2 combo is Anycubic Slicer Next, which is Orca Slicer with a different name. And from what I can tell, it's also the only way to use the printer's network interface, short of using their cloud services. Now, the protocol that they're using for the local network mode is not documented, and it does not allow you to just open up a web browser and point it to port 9883, which Anycubic Slicer Next is using to talk to the printer. Even on the local network, that communication is encrypted, so that put a quick stop to my attempts to reverse engineer the interface. The one thing I did figure out is that the webcam stream from the printer is accessible as an unencrypted video stream to anyone who has network access to the printer. But the communication between Anycubic Slicer Next and the printer does lack any sort of login or authentication. So anyone on the network can also fully control the printer. So I'm not sure what that encryption is supposed to achieve then. There are some projects that allow you to integrate this printer and many of the other Anycubic printers, for example, into Home Assistant through the Anycubic cloud. But if there's anything that I've learned about cloud-based infrastructure, that the only thing that you can take for granted with them is that eventually they will be shut down and whatever uses those will just stop working. That's really what Stop Killing Games is all about. But you know what? None of this is actually too critical, because Anycubic thankfully left so many security holes in this printer that it is trivially easy to gain root access on the machine, add a full clipper, mainsail, fluid interface to it, and customize it to your heart's extent. To install the Ringhals mod for this, all you have to do on this machine and on many of the other Anycubic machines is to plug in a USB drive with a specifically named folder, and the printer will just happily run any executables that it finds in that folder on the Android system. Ringhals adds back all the customization options you would expect from a regular clipper-based printer. Gives you a root shell through SSH, and I genuinely think this project and the security flaws that make it possible are what makes the bugs and just overall somewhat incomplete development effort from Anycubic's side bearable. A couple more things that I do want to get out of the way before we get to a conclusion. Again, keep in mind that these are the sort of compromises that are made to make it possible for you to buy this printer for $250 or $350 with the multi-material box. If they had spent the time to fix all these things, then this would not be a printer for $250 anymore. The screen on the printer turns off when it's idle. Cool idea for energy saving and making that screen last a bit longer. But then why does the printer not turn off its LEDs and fans when it's idle? Those are pretty noisy. Then the only way to get the screen active again is to touch it, because it's a touchscreen. And when doing so, you actually press whatever button your finger lands on, even if you couldn't see it at all. This is particularly irritating when the printer is trying to show you a filament runout message in the middle of a print, because you might accidentally just cancel the print or do some other stuff that you did not intend to do. On the note of that filament runout sensor, yes, it has a filament sensor in the toolhead, but the assistant to swap filament on the printer does not work. It actually got me stuck in the load and unload filament screen, and the button to resume the print just did nothing. I did eventually finish the print by going to the Anycubic Slicer Next network interface and pressed the resume button there. The heat bed has no insulation underneath. The front USB has this weird rubber flap, but because you're always going to have a USB drive plugged in and the webcam over here, that flap is just pointless. And when you swap filament, the printer always preheats to 250 degrees, no matter what filament you have preloaded. It knows what filament is in the machine, but it chooses to ignore it. And maybe one that might actually be a bit of a problem in the long run is that whenever you send a file to the printer, it seems to store it on its internal storage as well as to the USB drive, from what I can tell. The Rockchip SoC seems to have 8 GB of flash, with a bit less than 6 GB usable, and there seems to be no way to delete files off of the internal storage, neither through the printer itself nor through the local network interface. I don't know what happens when that storage runs out, but I guess if you're using the printer with the networking function, you will eventually find out. Now, one thing that I really do like how it's been implemented is the Ace Pro multi-material switcher add-on. Remember, this is just $100 extra as a combo deal, and it turns this printer into a 4-filament multi-material machine. What's cool about the Anycubic Ace Pro is that it also serves as a filament drying box, which can cost just as much just by itself. It has a little heater built in, and that just makes sure that filaments that are moisture sensitive, like PETGs, just stay at a more printable state for longer versus leaving them out in the open, exposed to ambient air. And Even if you don't use the multi-material printing option, I think it's actually a good deal just for that drying function. And since multi-material printing with a multiplexer system like the ACE, the MS, the MMU is pretty wasteful anyway, where sometimes you're using more filament to purge the nozzle between filament swaps than for the actual printing job, I think the best way to use the Anycubic ACE Pro is to just keep your 4 most used filaments loaded up and use it as a filament selector for single material printing. For example, on the robot arm, I've used tons of black, gray, and white PETG and a bunch of white PLA. And with something like the ACE, I wouldn't have to swap filaments by hand at all. And if you really need to, you can still use it to print, for example, PLA as a support material for PETG, or do that multicolor printing thing that I personally don't care much for, but it seems to be something that people do enjoy. So all of this puts the Anycubic Kobra 3 V2 combo into a bit of a weird spot. On the one hand, it tries to do a lot of things, and it gives you a huge amount of features for honestly a very reasonable price. But on the other hand, many of those features are not implemented particularly well and require you to step in and make them work for you. Even though this printer is priced as an entry-level option, I don't think it's actually that suitable for a beginner user. The best use for this printer is going to be someone who already has some experience with 3D printers and is able to work around or fix things like the bed leveling issues, which I think is an actual deal breaker on this machine. You're going to get the best use out of this machine if you're willing to run the Ringhals mod on it, root it, and then tweak it using the full range of options that the unlocked version of Clipper is giving you. If you're willing to do that, I think this is a worthy successor to the Ender 3 line of printers, which has actually always been used in that same way. The people that got the most use out of them were the ones who spent the time fixing the things that the manufacturer didn't want to spend the development effort on. There you have it, the Anycubic Kobra 3 V2 combo. Definitely not perfect, but if you're looking for a project or simply for a budget option and don't mind tweaking it yourself, then it's definitely worth a look. Links in the description below. As always, thanks to everyone who is supporting the channel through YouTube memberships or Patreon. Your support does mean a lot to me. Thanks to everyone for watching. I hope to see a bunch of you at Open Source next week, and I'll be bringing this guy along. Until then, keep on making.